In this lesson, I will be talking about the order of operations in great detail. The order of operations is first taught probably as early as pre-algebra, maybe even a little bit before that, definitely reviewed in Algebra 1, Algebra 2, and well into calculus. We always have to keep in mind this order of operations so that everybody working on the same problem comes up with the same solution. So you may have remembered or been taught little sayings, PEMDAS, or please excuse my dear Aunt Sally. So I do want to review what those pieces of the order of operations stands for. So the P in PEMDAS, or the P in please excuse my dear Aunt Sally, really means parentheses. Any calculations that are contained within parentheses need to be taken care of first. But parentheses are just one type of symbol you may see. We may see different brackets. What we really call these, though, are inclusion symbols or grouping symbols. So again, the most popular, most common kind we do see are parentheses. They could be square brackets. And for the more complicated symbols, if we already see parentheses that are used or the square brackets that are being used, you may see another type of bracket. This is called a set bracket, or I like to just, when I tell my students, it's a squiggly bracket if we can try to draw them as best we can. Some other types that we may not be familiar with or see as inclusion or grouping symbols is the fraction bar, because it separates the numerator. I'm just going to denote that with a capital N from the denominator. So instead of grouping, it sort of separates, which is a way to group as well. So all the terms that are going to be in the numerator, those get combined. And then in our denominator, and since a fraction bar really stands for division, we combine everything in the numerator, then everything in the denominator. Then if we can divide at the very end, we do that, or simplify the fraction. And yet another type as well is absolute value. If you've dealt with these types of symbols before, you may be familiar with it, but absolute value is just the vertical bars that surround a calculation. Could be just one number, but if there's more than one number being calculated in there, we definitely want to take care of that first. So we might see something like a 2 minus 5. So we take care of everything that's inside the absolute value bars and then take the absolute value of that final number. So after parentheses, we look at exponents. Exponents is a different way to write multiplication, a little quicker. So if we have, let's say, 4 to the third or 4 cubed, the 4 is our base, and then the 3 is the exponent. If you do need more review with exponents, I will also have a lesson created dealing only with exponents and going into great detail the laws of exponents. So one description of this, 4 cubed, the exponent simply tells us how many factors of the base we're multiplying, or how many factors of 4 in this case we're multiplying together. So that means 4 times 4 times 4. 4 times 4 is 16, and 16 times 4 is 64. So if we are looking at a problem that we're trying to simplify or evaluate, we want to first take care of any calculations that are contained within parentheses, and after that, any problems or any parts of the problem that involve exponents. After exponents, the saying is multiplication and division. I'm just going to put a hyphen here. And it's really as we read it left to right. And here's why. Division we can write as a fraction bar, but it's not always presented in a problem as such. So I just want to give you some different ways to look at this, and then when we go over some examples, you'll see how this is applied a little more as well. So if we're looking at, let's say we have 18 divided by 3 times 2. So I always want to address this left to right. So the first operation I come across is 18 divided by 3, which will give us, write it underneath here, 6 times 2, and then 6 times 2 will give us 12. Another way to look at 18 divided by 3 is as a fraction. So if this problem were originally written as 18 over 3 times 2, it probably wouldn't confuse us as to what to do first. We have to take care of 18 divided by 3. If that's the case, then times 2. When we look more at fractions, I'll have a separate lesson on how to multiply and divide fractions along with adding and subtracting. There's another way that we could look at this. We don't always have to multiply, divide left to right. If we're familiar enough with adding and subtracting, multiplying and dividing fractions here, I could think of this as 2 over 1. So 18 divided by 3 times 2 over 1. Yes, it's still easiest if we divide that 18 by 3 first to still get a 6 here and then multiply that by 2. If not, I could still just multiply straight across 18 times 2 divided by 3 times 1. So as we go over more examples, I'll describe that in a little bit more detail. But again, this is just one way that we want to make sure that we're looking at multiplication, division, left to right. And then the last two, also left to right, is addition and subtraction. So in any case, just a brief example here, if I have 5 minus 2 plus 3. We still want to go across. I have another lesson on adding and subtracting integers, and that's what we're looking at here as well. So no matter what order you put these in, we have to consider the sign that's in front of them. So notice we're looking at this 5. If we're only looking just at the 5 is positive. In the middle, if I'm only looking at this 2, the 2 is negative. And then this last 3 is positive. So if I were to just go from left to right, 5 minus 2 would just give me 3. Then I would add the other 3 to get a 6. So if you wanted to try this in a different order, let's say we wanted to add the 5 and the 3 first. I'm just going to write it that way. We'd have 5 plus 3 and then a minus 2. So notice I still kept the minus or the negative with the 2 that's here. So now I would add the 5 and the 3, and that would give me an 8 minus 2, which I'd still arrive at a 6. So no matter how you wanted to do this, just make sure you keep the sign in front of the number, and then technically you can add or subtract out of order. But if you're just following along left to right, we want to do whatever comes first. So now let's take a look at some examples. So here the directions may say simplify, evaluate. As long as we're dealing with numbers only and there's no variables brought into the problem yet, technically, yes, we could say simplify or evaluate, and everything just kind of simplifies down into one number. All right, so I'm going to underline one step at a time. Once you work with these enough, you'll be able to see what we can kind of do at the same time and combine some steps so we don't have to show every single step. So let's go through our list again. We have parentheses, exponents, multiplication, division, left to right, addition, subtraction, left to right. So yes, we do have parentheses. So I'm going to underline just what's in the parentheses, and I'm only going to change that part. So 6 minus 2 is going to give me 4. And I'm just going to rewrite the rest of the problem. After that, even though I do have the 4 in parentheses, it's only one number, so it's not like there's a calculation to be done inside. Technically, because the 4 is positive, I didn't really need the parentheses around it, but what I do have now are exponents, so I want to take care of that. And we saw on the previous page, 4 times 4 times 4 turned out to be 64, so I'm going to leave that as 64 plus 2 times 4. Now looking at this, I'm adding and then I'm multiplying. Well, if you remember, multiplication, division before addition, subtraction, so I need to multiply the 2 times 4. So this will give me 64 plus 8. And then I only have this one calculation left. So if I add 64 plus 8, I end up getting 72. Take a look at another example. We have 22 minus 4 squared plus 6. In this problem, I don't have any parentheses, so my next step is to take a look at any exponents I have. So if I notice this here, I do have 4 squared, so that's the only thing I'm going to change. Right now, this minus sign, I'm going to treat it separately. This is still just saying 22 minus whatever this 4 squared is. So that's going to give me 22 minus 16 plus 6. So I no longer have any exponents. There are no multiplication or division, but I do have subtraction and addition. So remember, it's whatever comes first. So right now I'm just going to go ahead and subtract this 22 minus the 16, which will give me 6. And then the last bit is 6 plus 6, which will give me 12. Take a look at another example. I have 40 plus 16 divided by 2 times 5. I'm going to pause. If you want to pause the video for a moment, just look it over yourself and determine what do you think we need to do first. Again, if you wish to just go through the checklist, we don't have anything in parentheses. There are no exponents. If you look at multiplication and division, we do have one of each. What should be done first? If we're looking at this, 16 divided by 2 is the very first step we need to do. So we'll have 40. 16 divided by 2 will give us 8. So after I take care of division, next I still have multiplication here, so I need to do that before I add. So I'm going to multiply 8 times 5, which is also 40. And then my last step is just to add 40 plus 40. Do a few more examples here. Okay, here we have 6 squared minus 4 times 9 divided by 2. Again, go ahead and pause the video for a moment, see what you think needs to be the first step. Again, if you notice, there are no parentheses, but we do have exponents, so I want to take care of that first. 6 squared means 6 times 6, so that'll give us 36. Then I'm just going to rewrite the rest of the problem. Okay, now if you notice I have subtraction here, but I can't do anything with that yet because I have not only multiplication but division. So again, in this case, just to keep things easier, we want to follow multiplication, division left to right. So then my next step is to multiply the 4 times the 9. That will also give me 36, and then divided by 2. And just like in the last problem, I still have subtraction here, but because of this division, I need to divide that first. Just to show you another way to even just write this step out here, we have 36 minus 4 times 9 over 2. So if you're familiar with fractions, this is another way to do this. Now, technically, we could have divided the 9 by the 2 first, but then keep in mind we'd still have to multiply that by the 4. Or we could look at this as a 4 over 1. But because it's written out horizontally like this, we definitely want to follow the order of operations with multiplication, division, left to right, just so we don't make any little mistakes. So continuing with our problem, I end up getting 36. Keep that minus sign there. 36 divided by 2 will give us 18, and 36 minus 18 is 18. All right, let's take a look at another example. This time we're going to have several sets of parentheses, or a couple sets rather. So if you notice, we want to kind of work with the innermost set of parentheses first, just to make it easier, and then we work outwards as well. Even though we see this problem, I'm actually going to add something else to this here. Let's just do a times 2 at the end. Otherwise, there wasn't really a need to put the larger brackets around everything. So we want to work with the innermost set of parentheses first. All right, so if I take a look here, that's working inside this set. So just contained within that set, I have 4 squared minus 10, and that's the only thing I'm going to change right now. Right now, we could kind of look at all this together. 4 squared, I'll still write this out, is 16 minus 10. But if we wanted to go ahead and just say that that was 6, that is perfectly fine. So I'm still contained within that set of parentheses. And that will just give me 6. I could have written the parentheses as I did, or just wrote it like a little multiplication dot there to show us that this is 22 minus 3 times 6, but it's still necessary to keep that last bracket there, then the times 2. So now my next set, I'm looking at what's inside the brackets here, but I can't subtract just yet. I want to just take a look at that 3 times 6. So I get 22 minus that 3 times 6 will give me 18. So now, because I have this set of brackets here, this tells me I'm definitely going to subtract before I multiply, because the subtraction problem is contained within the grouping symbols, and anything within the grouping symbols I need to calculate first. So 22 minus 18 will give me 4. Now I can multiply the 4 times 2, which is 8. And just to also show you, if you were to check these on any type of calculator, make sure you're typing in the parentheses the same way they look here. If you forget parentheses, it could definitely change the answer you're getting on the calculator. All right, so I'm going to have you guys go ahead and try this one. Go ahead and pause the video for a moment, work from the innermost set of parentheses out, and see what you come up with. All right, the innermost set of parentheses contain the 4 plus 3, so I want to go ahead and calculate that first. Again, I'm just going to rewrite everything else. Now, as I take care of this 4 plus 3, there's no need to keep that number itself inside the parentheses, so this just becomes the 8 minus 7. After that, the innermost set of parentheses is that 8 minus 7. 8 minus 7 will just give me a 1. Again, inside the brackets here, or that grouping symbol, is just the 30 minus 1, so I want to subtract before I multiply. And try not to rely a lot on calculators. If you're not sure what 29 times 4 is, just do that off to the side. We're going to do this. You're going to see me do this quite a bit for multiplication and division. If you remember going back to when you first learned multiplication, definitely do this. You'll thank yourself later for taking the extra time instead of always relying on a calculator. 4 times 9 will give us 36. Remember, we put the 6 down. We'll carry the 3. 4 times 2 is 8. 8 plus 3 will give us 11. So our final answer here is 116. All right, and I just wanted to show you a few more involving absolute value and then some with fractions. So if you remember, and this is a little lesson within a lesson, absolute value is always going to turn out to be positive because it's the distance that a number is from 0. And distance is always positive. So if I have the absolute value of -3, that's just going to turn out to be a +3 because -3 is still 3 units away from 0. If I have the absolute value of 2, that's still going to just stay a +2 because 2 is still just 2 units away from 0. So applying this to order of operations, if I have the absolute value of 7 minus 10, actually I'll make this one a plus the absolute value of 3 plus 2. What I want to take care of first is the 7 minus 10. And pretty much I could do this at the same time over here because they're two separate grouping symbols. I still need to keep the absolute values around these. So 7 minus 10, if you take a look at my lesson on adding and subtracting integers, I mentioned if we don't have enough, I always turn this into terms of money. So if we have 7 and we owe 10, we're going to be short 3. So we have the absolute value of negative 3, and then 3 plus 2 is 5. So next we're going to take the absolute value of each term. The absolute value of negative 3, as I mentioned or showed a little bit ago, is going to be a positive 3, and then we have a positive 5 here. So our final answer is 8. And one more example we'll take a look at with fractions. Say we have 2 times 5 squared minus 10 over 2 plus 3 times 4. So this fraction bar, this is a division bar, we want to just simplify the numerator and then simplify the denominator. So within the numerator, I need to square the 5 first. So that's the only thing that's going to change. So 5 squared will give me 25. So 2 times 25 minus 10. And then in the denominator, since they're separate, I could take care of the first parts of each part of the fraction at the same time here. So I could take care of that 2 plus 3, which will give me 5 times 4. Okay, after that, back to the numerator, my next step would be to multiply 2 times 25, which will give me 50 minus 10. And then in the denominator, I can multiply those two together to get 20. I still have one more calculation in the numerator. 50 minus 10 will give me 40. So this is saying 40 divided by 20, which will give me a 2. Now, if you were to type this into your calculator, you would want to make sure you put parentheses around the numerator, and then parentheses, and again, parentheses of the 2 plus 3 in the denominator. So this was a little lesson over the order of operations. If you have any more questions, feel free to email me at help@thealgebratutor.com for further questions or if you have a particular problem. Thank you.